Okay, so we are on lesson 37. And our target for today is I can multiply a whole number and mixed number by using the distributive property. So if you guys remember distribute, that word, a distributor is someone who gets things out to people. So to distribute is kind of like to, give out. And so that is what it's something that's also used. It's a term in math. And so that's what we're going to be learning about today. We've actually talked about it in the past, but that's what we're going to be focusing on for today. Okay. So Ms. Corley is going to do, this is one problem that you guys will encounter today. And so I know that this kind of was potentially confusing in the previous lessons, last two. So I just wanted to show you guys how to do this. So this first one says to draw a tape diagram to show the product of a whole number and a mixed number. So if you guys can please write this problem down, it's 2 times 3 and 1/5. Okay, so write this in your math journal so that you can have this as an example. So the steps that we take, I'll give you guys a second to write this. So again, it's 2 times 3 and 1/5. And it says to draw a tape diagram to show the product. So the very first thing is we're going to identify the mixed number. So 2 is a whole number, right? That's not a mixed number. 3 and 1/5 is our mixed number. So what we do is we're going to draw a tape diagram to represent just one copy of 3 and 1/5. And so when we do that, our tape diagram, it's a whatever, a rectangle. We need to make it so that it represents that 3 wholes should be way larger than the 1/5. Wouldn't you guys agree? So this would be, I just did that. Whoa, that was really bad. Okay, so this is technically my 3, okay? And then this part right here is the 1/5. Okay, so I have 3 and 1/5. And since I am doing what to it, I'm multiplying it by 2. That means I need to make another copy of that. So attached to this same tape diagram, I'm going to make another one that's the same size, almost. Sorry, it's hard to do this on the computer. And this is also 3 and 1/5. And I apologize again for how it's not necessarily the neatest. So again, we just made now 2 copies, which is us representing this. And what's our final answer? Well, we know that we can add these 2. We know what 3 plus 3 is, right? Or 2 times 3, it's 6. So how you write this is we'll do 2. I'm going to rewrite the problem. 2 times 3 and 1/5 equals, well, first what we're going to do is 2 times 3, which are our whole numbers, and you're going to put that in parentheses. So that's a parenthesis, because it's easier to multiply those whole numbers first. So 2 times 3, and then, so we did 2 times our whole number. Now we have to do 2, so it's going to be plus, beginning parentheses, plus 2 times the 1/5. Okay. And again, I'm sorry that my parentheses are so sloppy, you guys. So then we know 2 times 3 is 6, right? So we just solved this part, so write that down, please. And now plus, what's 2 times 1/5? Well, if you guys remember from yesterday, we don't multiply 2 times the denominator, we only multiply it times the numerator. So 2 times 1/5 is 2/5. So it's 6 plus 2/5. So our final answer is 6 and 2/5. Got it? So that's using a tape diagram to show the product of a whole number and a mixed number when multiplied. Notice what we did is we distributed the 2 to the whole number of 3. We did 2 times 3, and then we distributed it to the 1/5. So that's what the distributive property is. All right, Louis, I need to be able to see you, dude. Does anyone need more time to write this down? No? Okay. Moving on to the next problem. So it says, I don't want to add any text. It says, make a tape diagram to show 4 units of, sorry, hold on guys, I want to delete this. There we go. So make a tape diagram to show 4 units of 5 2/10. I'm sorry, I couldn't get this to go into fractional form. So we're going to be making a tape diagram to show 4 units of 5 2/10. Then write a multiplication expression to represent the group. So the very first thing we're doing is making our tape diagram. You might want to note that. And it's to show 4 units. That means times 4. And then we need to write a multiplication expression. So I would like you to, you're going to do this one with me as well. Okay, so step 1 is going to be, we need to do 5 2/10, right? We need just 1 copy. Bella, do you have a question?
It's not really a question, it's a comment. Cause like I forgot, I don't know where my problem set is.
The UPS man has arrived. If you couldn't tell, Mowgli is freaking out. Sorry. Mowgli, hey, come here. Mowgli Gourlay. He is so bad. Mowgli, okay, he's gone. You scared him away. Psycho. Okay, sorry, Bella, what did you say? You don't have your problem set?
I can't find it, and so like I won't know what like the problems are.
Okay, so it's linked on your Google Classroom assignment, so you can copy the problems down from there.
Okay.
When we get to that, okay?
Okay.
All right. Okay, guys, so we need to first make our tape diagram. So the very first thing is just to make it a 5 2/10. I'm just going to do one like this. And I need to draw. So we'll say that right here is the 2/10. I'm going to label it. Oh, I guess I could do this. So that's going to be 5. And right in here will be the 2/10. Whoa. So then you guys, so that's the 2/10. That's only 1 copy. How many do we need to do? Show me with your fingers. Okay, it's not 10, it's 4. We need to make 4 copies of it because it says to show 4 units of. So what you would do is you would just take your same tape diagram and make 3 more copies. I'm wondering if I can do that. Come on. I don't know, it's not working. Mine's gonna be a little sloppy. Whoa, 1 copy, 2 copies, which is a total of 3, and 4. Don't judge my drawing, and I expect yours to be way neater than Miss Gourlay's, because remember, I have to use just my pointer finger to do this. So this is 5, and this is the 2/10. Okay. I'm gonna not continue to label this. What I'm gonna do instead is I'm gonna show you guys how we then represent this down here. So as a multiplication, I guess actually I kind of need to have this because 5 and 2/10. So you can see, this is so sloppy. Okay, to turn this now into multiplication, how many, like, what do you guys see here? We have 1, 5 and 2/10, 2, 5 and 2/10, 3, 5 and 2/10, 4, 5 and 2/10. So what we would do is, as a multiplication expression, it would be 4 times 5 and 2/10. Right, guys? Because it says show 4 units of 5 and 2/10. So as multiplication, it would be 4 times 5 and 2/10. Now again, to show our distributive property, we go equals. Okay, let's do the whole numbers first. So we're gonna do 4 times 5, because 4 is the whole number, 5 and 2/10 is our mixed number. Otis, are you following along, dude? Because you guys should be writing this with Miss Gourlay. So 4 times 5, and now I need to do plus, and now 4 needs to be multiplied to the 2/10. So plus 4 times 2/10. And then we can now solve. 4 times 5 is 20. And then plus 4 times 2/10. Louis, you should be, where are you? He's just gone. Okay, 20. So now 4 times 2/10. Again, we just multiply the 4 to the numerator. So 4 times 2 is 8/10. 8/10 is not an improper fraction, is it? We don't need to simplify it. So we just add those two together. We get 20 and 8/10. Louis, what are you doing? You need to be watching and participating in the math lesson, bro. Okay. You guys ready to move beyond just the visual? Yes? Because this is kind of showing you again the distributive property. Okay. I'm gonna clear my drawings. We're gonna move on. Okay, so now it's saying identify the distributive property to multiply a whole number and a mixed number. Write a number sentence to multiply the whole number by each part, then solve. So if you guys could please copy down 3 times 7 3/4. I'm going to be taking away the tape diagram. We don't need that, okay? And instead what we're gonna do is we're gonna take 3 times 7 3/4 and we're gonna jump to what Miss Corley just did, which was distributing our whole number to the whole number in the mixed number and then to the fraction in the mixed number, okay? So what we do, I will rewrite this. So 3 times 7 3/4 equals, so first we multiply those whole numbers, equals 3 times 7, put that in parentheses. So I distributed the 3 to the 7, and now we need to distribute or multiply the 3 to the what? Unmute yourself.
3/4.
Nice work. So yes, so now we do plus 3 times 3/4. And put that in parentheses. So we just now wrote the number sentence to multiply the whole number by each part. We multiplied the 3 by the 7, and we are multiplying the 3 by the 3/4. Now we need to actually solve. So below, I always line on my equal signs right here. So we know 3 times 7, right? And if you don't know it, you can either skip count by 3s 7 times or skip count by 7 3 times. It is 3, 2,
21.
1.
21.
Yep, 21. Good job, guys. 21.
21.
21
Mm,
plus.
21.
Okay. So now we have 21 plus, and now we need to multiply 3. Again, we don't multiply the 3 to the denominator. It's only to the numerator. So 3 times 3 is 9/4. Okay, so I just put this together, right? And our final answer is 21 9/4, correct? No, Miss Corley was trying to trick you. 21 9/4, you guys, 9/4 is an improper fraction. So we can't do that. We need to now turn 9/4 into a mixed number, right? Okay, so we need to take 9/4 and do a number bond. So I'm actually going to do this over here because I don't want it to get like confused with the equation. So let's take 9/4. And this was something I noticed some kiddos struggled with yesterday. Some kids were like, oh my gosh, how do I do 9 divided by 4? I don't know. Well, bring it back and remember, we're thinking about how many like 4/4 or 1 wholes go into 9. So we could do 4/4, which would be 1 whole. And then 4/4 plus another 4/4 is 8/4, right? Can I go any more than that? No, because I would go over 9. So we write 8/4 here, which leaves me with 1/4 still. And when I recompose this into a mixed number, 8/4 we know is the same as 2 wholes. And we just bring down the 1/4. So now we can come back to this equation and we go, okay, equals 21 plus 2 1/4, because 9/4 is the same as 2 1/4. And now 21 plus 2 1/4 is 23 1/4, because I can just add the 2 to the 21. Does that make sense? Remember, you should be copying this down so you have it as an example for when you solve. Anybody need more time?
Me.
Okay. I don't know who you are because I can't see all of you. Oops. All right. I'm going to clear this because the last problem I'm going to model for you guys is a word problem, okay? You don't need to copy down this word problem. You should have your word problem checklist out with you if you have that at home. If not, you'll be getting it soon whenever your parents pick up your materials. So I'm going to clear this. We're going to go through a word problem, and then you guys will have some time to work on the problems together. So here we go. This says, so again, you do not need to be copying this down, just pay attention, make sure you know what you need to do. So solve a word problem involving multiplication of a whole number by a mixed number. All right. So we have, I'm going to read it to you guys. In April, Otis ran in a marathon as part of a relay team. Oh, wait, I needed to fill this number in. He ran 6 miles and I think it's 50, hold on, yep. 6 miles and 55 100. That is so terrible. I apologize, but that's the best I can do. So he ran 6 and 55 100th miles, okay, as part of his marathon. Great job, or his marathon relay. If you guys know a relay team, it's like you do only part of it. You don't run the full marathon, okay? So again, in April, Otis ran in a marathon as part of a relay team. He ran 6 and 55 100th miles. In September, Otis ran 4 times as far. Keyword, 4 times as far. We know that means it's going to be times 4 to complete a marathon on his own. So this time he's not doing a relay. How far did Otis run in September? Okay, so we know that this is the number right here that he ran in April. And then we know that in September, he ran 4 times this. So our equation is going to be 6 and 55 100th times 12, 18, 34, 1.
4.
Yep, thanks, June. Times 4.
4.
Okay, that's our equation. 4 times as long. Okay, so if you want to do a tape diagram, you can, or I would just use the distributive property. So again, we need to take our whole number, which in this part is the 4, and we need to distribute it to the 6. Okay, multiply it to the 6, and then multiply it to the fraction. So the first one is going to be, first parenthesis is going to be 6 times 4, or you could write it as 4 times 6, plus And now we need to multiply 4 to the fraction. So plus 4 times 55 over 100. Okay. We can do 6 times 4, right? That's pretty easy peasy lemon squeezy. 6 times 4 is what? Tell me in 3, 2, 1.
24.
24.
Good job. 24. Okay. Plus, wait a second. 4 times 55. Oh my goodness, I have no idea how to do that. Panic mode. Okay, not panic mode. Remember standard algorithm. You put the larger number on top, 55 times 4. So first I need to multiply the 4, Louis, times the 5. 4 times 5. And then I need to multiply 4 times, not 5, but 50. And add those together. 4 times 5 is 20. I'm going to put the 2 in the tens place, a 0 in the ones. And 4 times 50 is 200. And then I can add them. 0, 2, 2. So what I really have is 220 hundredths. But that's not my final answer, is it? Is that my final answer?
No.
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 It's not my final answer because 220 is larger than 100. So I actually need to take 220 100ths and turn that into a mixed number. So I'll do that up here. 220 100ths. Okay, how many hundredths can we pull out of that? Should be a pretty easy answer. It's just 200 100ths, which is the same as, how many wholes? Yes, Eva, 2, thank you. Okay, so when I have 200 100ths, that's the same as 2 wholes. And then that leaves me with 20 100ths because 220 minus 200 is 20 100ths. So now it's going to be 24 plus 2 over 20 100ths. And I can just add 2 to 24, which gets me 26 and 20 100ths. And I'm still not done because I missed where I forgot something. Does anyone know what I forgot? It's been so long. I forgot to write a sentence answering the question. So how far did Otis run in September? Well, Otis ran 26 and 20 100th miles in September, which that's how long a marathon is, 26.2 miles. 0.2, that's, oh, this is getting close to decimals, which is what our next unit is. Okay, that's the word problem. So